Right, so what we have here is a limiting reagent example problem. I'm going to zoom in just a little bit more, hopefully make it a little more legible for you guys. There we go. So you might want to write these down, excuse me, because we are going to work this problem. So you can pause here until you've got it all written down. All right, so the balanced chemical equation is, of course, the first step in any stoichiometry problem, right? So we need the balanced chemical equation for this reaction. It's actually the first one from the balancing bell ringer that we just did today. So now what we have, every limiting reactant problem is actually two stoichiometry problems. So as a quick reminder on how to do a stoichiometry problem, right, first you need the balanced equation. You can draw a line and an equals mark. What goes on the line first is this part right here. And right now you're going to notice I've given you that this magnesium metal is Mg. Decided to make those just a little bit easier on you there. Grams is G is short for grams. Oh, excuse me. There's the bell over here at Carnes if you're not familiar with that. So we start off with that, and where do we want to end? Well, it asks me how many moles of magnesium oxide. So what am I going to do? I'm going to put that out here at the end. Moles is MOL, and magnesium oxide is MgO. All right, so now I'm going to switch colors. We're going to do the second step here. If I've got grams of Mg up top, I need grams of Mg on the bottom. I've got to get rid of grams of Mg. That's not what we need for our answer. So what can we do? We can always go from grams to moles of that same substance, because 1 mole of magnesium is equal to how many grams of magnesium? Well, remember, moles equals grams for molar mass, and that molar mass has to come off the periodic table. So if we really quickly pull up a ptable.com, and we go here and we look for magnesium on there it is, it's element number 12, the molar mass of magnesium is 24.305. I'm going to round that to 2 decimal places because that's all I need, but 24.31 grams of magnesium. That number came off the PTOT, periodic table of the elements, and 1 is always in front of moles. When it's moles to grams, always put a 1 in front of moles. So grams is 24.31 grams, and moles is 1 mole. That's true for molar mass of any substance. All right? Then we're going to switch colors. We're going to cancel out. Grams of magnesium on the bottom, gone. On the top, gone. Anything on the bottom and on the top, cancel out. We'll draw another straight line right here. And now we've got what's left is moles of magnesium. Well, that's not what we want. We want moles of magnesium oxide. So we're going to go from moles of magnesium to moles of magnesium oxide. So where do we get numbers to put in front of those? Well, now we're going to go up to the the balanced equation, and we're going to pull those numbers from the balanced equation. There's an Mg right here in the balanced equation, so that too is going to go right there. There's an MgO in the balanced equation, so we're going to put that too. That's the whole reason the first step of this is balancing the equation. We need those for that ratio right there. Little hint, some people call that the mole ratio, by the way. All right, now what cancels out? Moles of magnesium on the bottom, gone. On the top, gone. We are left only now, the only thing that we're left with is moles of magnesium oxide. There is a number here that cancels out, and a lot of people catch that, and they say, hey, there's a 2 on the bottom, gone, and a 2 on the top, gone. So less I have to plug into the calculator if I can let out, right? That doesn't always happen, but it's helpful when it does. Now you pull out your calculator, and we've got 12.2 times 1, right? There's a 1 on the top, multiplied by everything on top, divide by each thing on bottom. So we take 12.2 times 20 equals 0.50. You can round your answer to 2 decimal places for now. And that's the answer. So that's the first part. The second part, I'm going to pause my recording right here. I'm going to go down here, and I'm going to work this second part. All right, so it's going to seem like by the magic of video editing, like it's just going to jump right on up there. But hopefully you pause right here. You work this second problem. Let's see if we get the same answer. All right, so if you worked this problem correctly, you should get 1.51 moles of MgO. Where most people mess this up, where I see a lot of people mess this up, is in this 32.0. A lot of people put 16 there. If you're one of those folks, remember it's O2, So you need 2 times oxygen. Oxygen is 16. We've got to multiply that by 2, and that's where 32.00 comes from. These two came from the balanced equation. There is nothing in front of O2, but remember it's understood to be a 1 there. So that's why there's a 1 mole of O2 down here on the bottom. All right, now that we've got these two things, we're going to talk about something slightly different, all right, which is cake recipes, right? And so this is the work that we did before. We did a POGL where it showed you the way that a car is put together. I don't like putting cars together. I like to think about putting a cake together, right? If in our cake recipe it calls for 2 cups of flour, we go to the cupboard and we have 3 cups of flour, well, we could make 1.5 cakes from that. But then we go check our sugar. It takes 1 cup of sugar. We only have 1 cup of sugar, so we can only make 1 cup with that sugar. 2 eggs, but in our cupboard we have 8 eggs. That means we could make 4 cakes. 1 teaspoon of baking soda. Man, I tell you what, you always have way more baking soda than you ever need when baking until you run out. I never forget to buy baking soda. But if we had 694 teaspoons of baking soda, because it comes in a big container, we can make 694 cakes, except we can't. When we look at all the cakes possible, the one that jumps out of us, we only have enough sugar for 1 cake. Doesn't matter how much flour, how many eggs, how much baking soda we got. If we've all got more than enough of those guys, we only got enough for 1 cake, thanks to the amount of sugar. Sugar limits our production. The same thing happens up here. When we look at these two numbers, if we see that 0.50 is less than 1.51, so therefore, this little special 3 dots means therefore, we call it limiting reagent. Limiting reagent. You'll see some people, by the way, call it limiting reactant. I don't know, it's just a different way. We could just write Mg. If it asks us what the limiting reagent is, we could say it's Mg. Because when we start off with this much magnesium, we know we're going to only be able to make this much magnesium oxide. Even if we have 24 grams of oxygen, we can make a lot more with that much oxygen, but we don't have enough magnesium to make that much magnesium oxide. So here our magnesium, which is in our original problem, there's our magnesium right there. That magnesium is going to limit the amount of magnesium oxide we can make. Therefore, it is our limiting reagent. So all of these limiting reagent problems, you're only going to get 1 on the test because they take forever, because there are always 2 stoichiometry problems wrapped into 1. And you're going to take both of those stoichiometry problems and use them to determine what your limiting reagent is. But the good news is it's almost always 50-50. It had to be either magnesium or oxygen. It wound up being magnesium. All right, now you can work on your homework problems.